we want to show K is the unknot. Right? If we do this, this shows what? This shows that the unknot is prime. Because anytime you sum two guys together, get the unknot, the factors like K must be unknotted. That shows it's prime. Well, alright, so I guess if this is the unknot, like let's draw our little box picture on a string like the last time, on a big loop. So we know that so one thing I'm going to do in this proof to kind of make things easier is, we know this, there's actually a little bit there, but it turns out there's a little thing that I'm not quite going to explain, but if you think about it, you might be a little bothered. But it turns out to be kind of easy, but somehow it's a little bit, I feel like it's a little bit hard to explain, but it's a minor exercise in many non-theory courses. But this, we know we can untangle to get this. That's what it means for the connected sum to be the unknot. So we know this, but I'm going to, instead of thinking of a loop, I'm going to consider an infinite string. Okay? So instead of that, what I'm going to say is, instead of this, let's consider the picture where it's like an infinite string going like this. This just goes off to infinity. And this goes off to infinity the other way. So it's infinite. String sort of goes on like that, goes on like that. Okay, and then our assumption that this is unknotted means that so by assumption, this is our assumption. So we're assuming that K and J somehow magically cancel out and give us this string here, unknotted string. And what we want to show is that this somehow implies K is unknotted. Well, I guess let's try to mimic that proof. I guess we have to put infinitely many things along the string here. So let's put, I guess, so here's K, and here's J. Well, the string's infinite, so I can just keep putting stuff on it. So let's put more stuff on. Let's put K. Let's put J. Let's put K. Let's put J, etc. And the string's infinite, so I just keep doing it. Like, let's say I keep adding it to the right here. So it goes on. I guess I'll put a kind of dot, dot, dot there. But keep doing this. Keep alternating copies of K and J. So these are copies, right? So they're not in K in this box sort of area here. It's the same as the one I put there. Now, you might be like, why did I do that? Well, it's because I know K and J cancel each other. So K and J cancel each other. So if K and J cancel each other, then I can look at each pair like this, right? Even though it's infinite, I can look at the adjacent pairs like that. And I can, each one of these I know I can straighten out to be like this. So let's merge, I guess this is the box sort of course. I don't really need this step, I guess, if you already know what the trick is, but let's kind of make it look like the parentheses thing that I did before with the numbers. Okay, this keeps going on. Right? So I kind of, instead of thinking of these two separate knots, right, it's like the sum. So it's one knot that I think of as inside this box. Well, what is this? This is unknotted. I'm assuming. That's what I'm assuming. This is unknotted. So this, each piece becomes straightened out like this. So I guess straightens out like that, so it's unknotted. Okay? So you might say, okay, this is dumb. I knew K connect sum J was unknotted. You've put infinitely many copies, And of course the whole thing's still unknotted. What was the point of that? But there's still a point, which is we didn't regroup it another way. We can regroup it another way. So take the original thing, K, and what's next? J and K, right? Let's group that into J and K, right? Connect some, J and K, etc. Alright, keeps going on. So instead of, I just leave this guy alone, but J is next to K, so that's a connected sum of J and K. J and K are to connect the sum of J and K. So I just get something like this, and now you have to remember something we went over the last time. What was the thing we went over? Like the connected sum. Do you remember, Jesse?
Commutative.
It's commutative. So if K connects sum J is unknotted, then J connects sum K is unknotted. Remember the sliding trick where you can slide one through the other. So this is unknotted. So what does that give us? This gives K, and then this becomes unknotted. This becomes unknotted, so on. So if I can straighten it out one way so it's completely unknotted, and I can straighten it out another way to see that I still have only K left, well, this means K is unknotted. So K is, I guess K is the unknot. Of course, I could similarly show J as the unknot the same way. This completes the proof. So the funny thing is, of course, with the numbers, I got 0 equals 1, which is very disturbing. Here I got K equals the unknot, which is very good. That's what I wanted. Now, upon seeing this, people feel very odd. How many of you feel kind of swindled? Nod or feel swindled? Anybody else feel kind of like there's something I did wrong here? Yeah, but you won't find anything wrong. All right, so anyways, that's the proof. So that's Mazur's swindle. It's kind of my favorite knot theory proof. Any questions about this?
Why aren't we swindled?
Why aren't we?
Yeah, why haven't we been swindled?
Why haven't you been swindled?
Yeah.
See, that's a weird question. It's an impossible question to answer. I've given the best explanation I could. Unless you find anything wrong with it, the assumption should be that it's correct.
Well,
I can't prove beyond a reasonable doubt that this is correct if you can't find anything to object
Why does this
to.
apply to knots and not to numbers?
Because I guess the funny thing about knots is when you have a bunch of them along a row, like even if it's infinite, like if I look at adjacent guys, if they cancel out, it turns out I can just do that cancellation in that part and straighten it out. And somehow in this geometrical context where you have things next to each other and you kind of straighten them out in a different order, somehow that's valid, because I guess maybe one thing to think about is somehow this infinite rope that I constructed with all these guys on, somehow, it keeps things from like going awry because it's kind of there and I can represent it in different ways. But with the infinite sum, the sort of that object that's the infinite sum in a way is kind of it already kind of depends. In order to sum up stuff, it already kind of depends on how you do it. Like